All right, everybody, let's get this thing started. My name is Neil DeMazier. I'm Vice President of Sales and Marketing here at Imagine, and you are joining us for session number 6 of Imagine Academy Quarantine Sessions. This is something that we're putting on here throughout the course of this kind of interesting event that we find ourselves in, and just trying to provide a way for everybody to have a welcome distraction from all the strange times that we're in, learn a little bit about CAD/CAM technology, and hopefully come back from this whole thing a little bit better educated. So we're going to be getting going in just 1 second, but before that, a few housekeeping things. First, if you could do us a favor, keep your microphones and your video turned off throughout the course of the presentation. That will allow us to focus on the presenters. If you have any questions throughout the webinar today, absolutely ask them. Use the chat function here in Zoom, which you can find towards the bottom of your screen there. Just click on that chat icon and you can send a chat message directly to me. You can send it to the group chat. But either way, I'll be keeping an eye on it throughout the course of the presentation today, and I will field those questions over to our presenter at the opportune time. So any questions, feel free to share them throughout the course of the presentation. Another thing, for any of those looking for continuing education credit for attending today, we absolutely have 1 hour of CE credit available for viewing the webinar. You can send me your CDT number via the chat function here on Zoom. Or alternatively, I'll be providing my email address to everybody towards the end of the presentation today. You're welcome to send me your CDT or RD number after the fact, and we'll be sure to get those CE credits logged for you. Last but not least, these quarantine sessions that we're doing here at Imagine Academy, we are doing these every Wednesday and Thursday at 2 p.m. Eastern, 11 a.m. Pacific time until this whole thing blows over. So if you like what you see today and you want to learn more with us, we would love to have you. So feel free to join us every Wednesday and Thursday, 2 p.m. Eastern, 11 a.m. Pacific for the Imagine Academy quarantine sessions. So without any further ado, session 6, this is going to be hosted by one of our CAD/CAM techs and trainers. His name is Yaphet Elaias. He's been an employee here with us for several years and has developed quite a competency with HyperDENT. Actually used to work in our own milling center, programming HyperDENT for some of the milling machines there, milling bars and abutments and things of that nature. So Yaphet, if you could turn on your video and your audio, go ahead and share your screen with us. We can get things started.
All right, can everyone hear me?
Yep, you're good.
Wonderful. All right, thanks, Neil. So how's everyone doing today? This is HyperDENT How-To, Pro Tips to Up Your Nesting Game. So essentially what the goal for today is to make you guys a lot more comfortable and familiar with all the features that HyperDENT has, and ultimately create what you see as an STL on your screen as what comes out of your mill. Okay, so let's get started. And just like Neil said, if you have any questions, feel free to drop them in the chat, or if there's something I don't get to, feel free to contact us after. You can always call for tech support. Chances are, if you have bought one of our products or software or machine or anything like that, you've probably spoken to either myself or one of the other tech support staff. And yeah, we can field any questions that you have and try to get you on your way. So let's get started. Okay, so the first thing we want to talk about are toolpaths in HyperView. For those who aren't familiar with that, HyperView is sort of a sister app or an app that helps HyperDENT post-process and create your job files, essentially. You can also do a lot of checking to see if how a mill came out, if the job was calculated correctly, if something even came out of the mill where a tool broke, something else broke, part fell out. If you're running into any issues, the first step I would do is to check your toolpaths in HyperView. Okay, so if you ever have any troubleshooting, you'd come here. So I'm going to go over just a few of the features that are in HyperView when you're checking the toolpaths. Some things that I thought were super helpful whenever I was going through a job or troubleshooting, trying to figure out what's wrong. So I have a pre-calculated job right here. Okay, so to start, these light bulbs right here allow you to toggle the view of whatever you see next to it. Okay, sorry about that. So you'll see this list right here. The toolpaths list is the list of all the steps within the job that I calculated. You'll see over here that this is the STL I calculated. It looks like a screw retained crown, right? So when you're going through this, one thing you want to take note of, each step has a different tool next to it, right? So if I hover over any one of these steps, let's say I want to look at some of this roughing right here. The second I highlight this job, it lights up with the yellow where the tool path is actually the tool is actually going to go. Right. So what you want to pretty much do here is to check that everything is going where you want it to be. For example, if I wanted to make the STL over here transparent, so I can see if the screw channel, let's say this came out of the mill and the screw didn't fit through the screw channel. Common mistake, happens all the time with people. I would first go into here, make this transparent by right-clicking on Model. Model is your actual STL. As you can see, I can get rid of it, I can bring it back, but I can also change its appearance if I right-click to transparent. This is going to be helpful if you're trying to find anything that happened with the screw channel, screw seating, or screw fit area. Okay. Some other views you might want to toggle most of the time. You'll see you can get rid of the fixture. I wanted to check here. You can also get rid of the stock, which is essentially the blank. Up here, you'll find the name of the job that you just calculated, so you don't get confused if you were to rewrite this job. If something did happen where you needed to rewrite a job, it kind of depends on the machine, but the common way to rewrite jobs is essentially, it's pretty simple. If I select whatever number of jobs I want to get rid of, right-click and delete, it'll get rid of the jobs for me. Boom. So now I'm left with the same list in the same order. It's just going to start somewhere else. So if I ever want to rewrite a job and I don't want to start all the way over, if my machine doesn't allow to pause and start a job, I'm going to come back into here and rewrite it and create a whole new NC file, or that's also synonymous with job. When I say NC file, I'm also mean milling job. Okay, so over here you'll see the machine that you've calculated it on. That's another thing to keep note of. Make sure you don't mix up your machines. And then back to if I want to write this as a job, I'm going to right-click on the job name and press this button right here, right, NC file. You'll see the same icons up here. Either one will work. Okay, when you press that, you're going to get a list of all the steps and all the tools in each step. Okay.
Yaphet, one question we have here from the audience that has to do with importing the STL files. Jacob is wondering, has anyone ever had any problems with ExoCAD construction files? And he comments that he usually just ignores the default construction markings. Is that something that you've seen a lot in the past? And if so, is there a way to address it?
Sure. It kind of depends on the trouble that you're having with the construction info file, or that accompanying file that comes with STLs that you've designed in ExoCAD. If you're noticing that nothing is marked up, so for example, if nothing is marked up and you have a blank STL, there's two things that could have went wrong. I'm going to show you some quick fixes that you can try. So every construction info file is also just a text file at the end of the day. So if you remember that, then you can open this up in whatever text editor you have, either Notepad or something like that. And then you're going to want to come over to make sure that the file name of the STL that it's supposed to accompany is one, the same as the file name. So this is the file name construction with the construction info. And you want that to match your STL. So the way HyperDENT works is it's going to look in whatever folder you've clicked on your STL and try to see if there is a file with the same name that's also a construction info file. If first off, that's not matched, then chances are it's not going to see it as the same construction info for the same STL. Another thing that could be messed up is if you change the name of your STL file to something else, some other identifier that'll help you, organize things, or if you're sending it out to a lab, you wanted to change the name to make them know let them know that it's yours or anything like that. You're going to notice that the construction info file probably doesn't match, and that's mostly because in this text file there is a name .cad.stl. So I just did Control F to find. I typed in cad.stl because remember, every design that comes out of Exocad ends with cad.stl. So I'm going to find the next. And this name right here, this is the STL that it's looking for this construction info file. So if your STL doesn't match this name right here, it's just going to treat it as a separate file, has nothing to do with the STL that you're importing. If you've done this step and you've made sure that your STL file matches what's in the construction info file, but the lines are still messed up, that could be something got corrupt with the construction info file, or you got the wrong construction info file, or something like that. If that's the case, then yes, go ahead and just manually mark everything yourself. But it is a great time saver to just already have everything marked up for you. I will say that. Does that pretty much answer your question?
Sounds like that pretty much covers it. Yeah, thank you.
Yep, no problem. Okay. So back to writing a new job in HyperView. So after I've told it to write the NC file, it's going to bring up this list of tools. You can check it if you like, but then you just hit OK. So this is going to come up if you don't change the name of the file that you're writing. Because remember, at the end of the day, this is an NC file. It's going to be in a folder. If you have the same name, it can get overwritten. So this is essentially saying, okay, there's already a file named this in that folder. So are you sure you want to do this? Do you want to overwrite it? I'll say yes this time. But if you want to avoid this issue, also that's it. That's done. That's already going to be in my STL once this is finished, or in my NC output folder. If you want to avoid overwriting anything, you can also come over here, change the name to whatever you want. You can call it restart. That helps. Very simple. You can really name it to whatever you want. As long as it's a different file name, you're not going to need to overwrite anything. Don't know if you still want the old job file, but if you want to keep it for whatever reason, you can always just change the name. All right. And the last important thing that you want to take note of in HyperView, in this little app right here, is the simulation tab. Okay. So I'm going to reopen this job file actually.
And while you're doing that, Yaphet, we have another quick question here from the audience. Joseph is wondering if we, or HyperDENT really, has the ability to read contact data from 3Shape or Exocad. And I believe the answer is yes to both of those, right?
Yes. 3Shape works a little different. It does export a different file type, where Exocad has a .construction info file. 3Shape has an XML file and a PTS file. Those are the two accompanying ones that will help the most for HyperDENT. And yes, that does include the information. That is going to work a little different. You can't really just mess with the text and change it to the same STL name, the same way as construction info, but that's going to give you your best approximation of where all the markings are. And like I said, if there's anything wrong or funny about one of the markings, coping line, anything like that, you can always just delete it and fix it if you want to.
Gotcha. And just to specify, he was wondering about interproximal contacts. I'm not sure if that information gets carried through with a construction info file. Is that fair to say for interproximal? Really just margin?
Yeah. So there's not really a marking in HyperDENT for getting those interproximal areas. You have things like user-defined areas that I'll go over in a bit. But no, I don't think there's any just marking straight out that's going to mark the interproximal areas for you.
Gotcha. So the main function of that construction info file is margin line, and if there's a screw channel included, perhaps the location angulation data of that screw channel, but that's largely the function of that construction info file.
Exactly. And the cool thing about HyperDENT is it can detect small pockets in your STL file, and it would check that out or mail that out during maybe a rest machining step or something like that. But that specifically is going to depend on the templates or the milling strategies that you have installed into your HyperDENT. Okay, but as far as detecting it, HyperDENT does a great job doing that already. Okay, so I didn't show this earlier, but to open up HyperView, you're going to want to select. So I'm in version 9 right now. So if you don't have version 9, it may look a little different. When I select on something, it is highlighted in yellow. So most of the stuff I'll be going over today, I'm just going to be doing it in version 9. A lot of these features are also in the other older versions, but yeah, so you may notice something looks a little different. You can ask me about it. Chances are it's probably just a different look. So I'm right-clicking on this selected part after it's been calculated. You could tell because it's transparent. And I'm going to come over here to show toolpaths. That's how I opened up the HyperView before. Okay. All right. So as far as simulation goes, that's this tab right here. And that's pretty much if you don't want to risk running something through your mill without checking if the finishing is going to be great, or if you want to add something else to the facial side or something like that, you can always double check into here. Okay, without getting too into the weeds about all the controls and all the buttons that you see here, I know it looks a little intimidating, but the main ones you should focus on or worry about really is just the speed that you run the simulation. So what I like to do is take it all the way to the max, 50 times normal speed, and just hit this button right here to go to the end of the last job. This is if you want to simulate everything. So if I hit this, it's going to take a little while to go through all the steps, but it's going to have to go in order. And then you'll see at the end right here what the result is. You can see, if I zoom in here, you can see this is what that step is going to look like when it reduces on the puck, and so on and so forth. As you can see, it's just going to truck through if I let it keep going. You can always stop it. Or if you have a specific area of the job that you want to simulate or something like that, you can always highlight the said steps, right-click, and run simulation. That'll be the same exact thing, but it's only going to start at the jobs that you've included. All right. All right, like I said, version 9, most of you may be already familiar with it or used to it at this point, but it is relatively new. A few things that I'll probably be going over is C-clamp milling. Over here, as you can see, that's a little different, or when I say C-clamp, I'm talking about the open face fixtures, whether yours looks like this. This one is for specifically the IMS I-Core machines, but if you have another machine, it may look a little different. That has been changed a little bit in version 9, as you can see right here. I want to go over a full arch case, or nesting a full arch case, but as you can see right here, yes, that is a little better than what we had before. There's automatic undercut detection. That's going to come up every time that you try to move a connector. You'll see all these red areas. That's what that is. There's multiple ways to detect the undercuts on version 9, and I'll also go over that. A few other handy features that you may or may not already be using, these multi-layered pucks that you can create, and you can also create a part queue, which is this, queue or a line or visualize your STL database. Okay. I'll go over, let's see, I'll go over a multi-layer puck. Okay. So as you can see here, I've already created one. So if I get rid of this fixture view by coming over here, hide selected. Also, let me know if I'm going a little too fast with buttons or anything like that. I'm going to try my best to try to tell you exactly what I'm doing or narrate as I go along. All right.
Yaphet, actually, we got a real quick question here from Joseph. He's wondering how hard it is to change the strategy. Do we offer training on how to do this, or do you offer services for changing the strategies? So I'll answer part of that. Joseph, if we're your reseller here for HyperDENT, we can absolutely work with you to modify your strategies. But one thing you're definitely going to want to tune in with us on is actually the quarantine session we're doing a week from today, which is all about a function within HyperDENT V9 called Template Generator Lite. And that is a function that, that you work in conjunction with your resellers, such as Imagine, to allow you the authority to modify certain aspects of your templates and strategies to suit your specific needs. So if you need, a screw channel to be a certain, slightly different diameter, or you want a finer step over on your finishing tool to get a little bit better surface finish, that function, Template Generator Lite, allows you some of that control. So definitely join us next week. That's next Thursday at 2 p.m. for that talk. But Yaphet, any thoughts on that from your perspective on changing the strategies, working with a reseller like us to modify or change the strategy?
Yeah. So, I mean, Neil got most of it. Yes, there is the template generator that you can use to edit whatever template or strategy you have. If you do purchase this license so aside from the template generator Lite, there's the full template generator where you can do whatever with it if you're a little more advanced with HyperDENT. That is not an issue to train. If you do get that with us, you can always call tech support and we can help you change to your template to whatever you want. But we could also show you as we go along on how to use it and the basics of it. I can touch a little bit on that as well during this webinar. All right. So back to multi-layer pucks. You'll see this is what it looks like once you've actually created one. If I double click on this and I want to change or test the shade, if I hold the shift button down like this, you're going to get the shade that comes up as you're moving it around. Okay. To create multi-layer pucks, you're going to want to go to Settings, Blanks, Blank Types. And this is where you're going to get your list of all the types of pucks that you can create and use in HyperDENT. This doesn't only go for the multi-layer pucks. This is if you also maybe have a size that you purchased recently that you don't see in HyperDENT. You can come into here and create a new blank. Okay. To make a blank multi-layer, so let's say I have a 16 millimeter zirconia blank. I want to make a multi-layer version of it. I'm going to, so a quick shortcut I do is I just copy it. So now I have a second one. Now I can edit it. All I have to do is click this multi-layer option, but you also have to choose a color scheme. The color schemes are all dependent on what you create. So that's going to be this tab right here. So if I want to create a new one, hit that new button, name it test multi. And now I'm going to add layers to it. So I'm going to add maybe 4 layers per se. And you're going to change the height of those layers. This is also going to depend on your preference, but either whatever you do, you have to make the percentages add up to 100 at the end of the day. And then you get to choose the shade of each layer. Say I want to start off with an A2 and go down. I mean, a multiple layer puck probably wouldn't start at the shade, but you get the idea. You're essentially just getting it darker as it goes down and trying to emulate what you have actually purchased or what you have in your lab. Okay. And that's essentially the basics of the multi-layer pucks, not too complicated. Once you've added that, you'll be able to choose it later on, and it's going to have the same gradient makeup that you had before. All right. And that's just mostly just to help you visualizing and get your cusps right and all the colors right and the shade right. All right, like I said, we've gone over this. These are the multi-layer pucks. Automatic undercut detection. I don't really need to go into a demonstration of that because I could do that throughout the time that I'm using HyperDENT. Okay, so as you can see here, this is what version 9 looks like when you're moving a connector. If I double click on it, it'll look like that. And it'll also automatically show me all the undercut areas that will happen if I leave the connector where it is. Okay. So the undercut's important because you don't want your part to come out blocky. You want it to look like have the same contours exactly that you see on your screen. That's where this little line comes in. So whenever you're moving a connector, if you're on version, I believe 8.2 and above, you're going to get one of these green lines that goes around that shows you the height of contour on your STL, which is basically the best place to place the connector to reduce the amount of undercut that it has. Okay, so undercut that has nothing to do with the connector, you can't help. Don't make it worse by having a connector that ruins a whole side of a crown or whatever you're milling. Okay. The part queue. Part queue may be helpful for those who have trouble organizing their STLs or want something to be able to see their STLs clearly or pick a certain one from a large library. That is basically how you would open up the puck. It would open up an STL. It would look just like this. And to activate it, you're going to want to go into settings. So to set up the part queue, I'm going to go to settings, general. I'm going to come over to part tracking. This step right here, use part in queue. If I want to have that image that I showed you guys before, I'm going to check yes, and then yes to automatically fill the in queue. So I can choose what folder it's looking through. So if you have a database folder that specifically holds all your STLs, you just go ahead and put that file path right here. What I mean by file path is essentially the folder, the location of the folder on your computer. So right here it says default path. That's obviously not where you want it to go because that doesn't really necessarily reflect where I keep my STLs. So you're going to come over here, the ellipses. You're going to choose whatever folder you have STLs in. I have some STLs in here, so I'm going to choose this folder. Wonderful. And then you also want to make sure that it's looking for STL files. If you would deal with mostly OBJ files, I mean, well, you would just want to have it STL for here.
Yaphet, one quick question here from the audience. Claudio is wondering, how many supports do you put on the crowns for zirconium milling? Do you do it manually or use the 3 that come by default? What's your strategy when it comes to connectors in zirconium milling?
For zirconia, for the most part, I will do 2 or 3. That really depends on the size of the crown, how much you're really, because you can technically use 2 just fine. But I get paranoid sometimes. I don't want to have to remill something because it fell out. I'll put 3 on there, but I do not let it do just automatic. Let's see. So if this were zirconia, one of the connectors would be thicker, but I definitely want to do it manually because the automatic one might not place it in the best spot for you. So that goes back to what I was talking about before. So if I hit this automatic, it's going to just do that, which functionally will be fine. That'll mill out. That won't be an issue. But I can do better. So if I had it something like here, it's not going to be able to tell that this is a crown. So if this were a crown, for example, it's not going to be able to tell that you probably don't want connectors on your contact points. You can see right here, if I double click on that connector to move it, there's going to be this whole area right here that's going to be undercut. So I'd want to move it up for starters. So I wouldn't just blindly trust the automatic placement, which it's a good starter for sure. I would definitely just put the automatic connectors on there and then just move them so I don't have to add it as I go on, or you can just manually do the whole thing. But either way, you definitely want to double check the placement if you just throw it on there automatically.
Great, thank you. Got a couple of other questions coming through here. This one's kind of a doozy, but if you could try to summarize it, what are the differences between the old and the new interface? I know there's a lot to unpack there, but in your opinion, having used both of them, Yaphet, what are the main differences in your experience?
Well, so there are two. For those who aren't familiar, in the version 9, there's a compact version that the interface looks completely different. The one I'm using is the older interface. The newer compact version is a little more streamlined, and it actually is easier for you to just walk through a case without forgetting any steps. This is just the one I've been used to. That's why I was just using this one for now. But that one is definitely a lot easier to make sure you don't forget anything, and also just make it a lot more user friendly. This one, that might have a lot of buttons at you that you may not understand or even use, but the other compact one, actually, I feel like does a little better of a job making sure that you're using the stuff that you actually need. Does that make sense?
Yeah, I think, and I agree. A lot of the feedback that I've heard from users on the more modern interface of HyperDENT is that it still has all the same power under the hood. It just gives you a much more streamlined user experience that allows you to just get, your typical run-of-the-mill bread and butter crown and bridge stuff, just get it through there very quickly and easily while still having all the power to handle the much more sophisticated cases. Still at your fingertips, just with a much cleaner workflow.
Exactly, yeah. It's just the skin. The functionality should be exactly the same as this one. Is there any more questions?
Looks like just about it for now.
Okay. Well, let me demonstrate the part queue. So if I want to, after I've activated the part queue and I want to load a STL, so if you don't have the part queue, you usually have that file explorer that opens. Now you just have this. And you can still filter stuff. So if I had more STLs in here, it would obviously be longer, but I can also organize them by say, okay, I needed a crown or I needed a bar, so on and so forth. Can we limit it based on that? And also at the same time, you also get this picture preview that you can mess around with if you need to. Okay. And that's new in version 9.
Actually, a real quick one here, Yaphet, back to the connectors. Regardless of whether you're using 2 connectors or 3 in zirconium, what diameter and shape do you suggest so that they don't fall apart or fail before it finishes milling?
Sure, 1 second. Here's a good example. Sorry about that. Okay, I'll just go with this one. So this is the titanium one, but when I'm choosing connectors, you'll notice that there are parameter profiles down here, okay? So if you have a parameter profile for zirconia, most of the time, whatever is default will probably work best. So the diameter that I typically use for zirconia is around 3 millimeters. You don't have to use that. I've just noticed that I have had the least amount of fails with about 3 millimeter diameter. As far as the angle goes, the angle is also going to help you keep more stability. If you're worried about things falling out, you can always create a larger angle, which is going to make a more conical shape. For example, if I did a 10-degree as opposed to the default 3 here, I click on that, it's going to make a more conical shape, which is going to provide you more stability while also reducing the amount of area that it takes up on the STL itself. So you get both. You get a small disturbance on your STL, but also a large enough anchor that you don't have anything falling out. So if you're ever worried about something falling out, you don't want to mess with anything, but just make sure it's more sturdy. You can always just increase this angle right here. But yes, 3 millimeters is about what I would use for zirconia.
Great. A couple more questions here coming through from the audience. We have one person wondering, will the software recognize ASC crown automatically, or do you need to indicate it manually?
So that's going to detect, so ASC, I assume you mean the angled screw channels. That's going to get noticed automatically in HyperDENT. It's going to get noticed automatically in HyperDENT, and a lot of the times that's going to be marked automatically with your construction info file or whatever accompanying file you have with your STL, depending on how you designed it. If there is an angle in the screw channel and you grab it, there is going to be a checkbox. So if you come over to implant interface, this checkbox right here will be checked off if it detects that there is an angle in your screw channel. This is not a checkbox that you check yourself. I've had a lot of questions about that. It's more of an indicator. This is just a little notice that says there is an angle. So with that being said, when it gets calculated, it's going to use a different set of strategies depending on whatever template you have on your computer. So yes, that does get get selected automatically or identified. If I didn't have this selected and I want, it's hard to answer because different templates have different ways of doing angled screw channels. Ours is one way where we just select one angle on there and get everything on the cavity side through abutment finishing, but people do it all different sorts of ways. HyperDENT does support angled screw channels, so it isn't an issue if you have an angled one there. Your template just has to support it. Okay.
Great. One other question we have here. We have somebody wondering, where can we see the burrs or cutting tools that you have on each strategy and the position for them in the milling machine?
Okay, so position for them in the milling machine, that's all going to be on your machining side. That's not really going to be dictated too much on HyperDENT, or at all, really. As far as the tool types and what's going to be used for each job, that's all going to be in your tool paths. So if you have template editor, sorry, 1 second, looks like it got frozen. Okay, so if you have template editor, you will be able to, sorry, 1 second, there's some technical difficulty.
Just while Yaphet's working this out here, Kyle has commented that he's using HyperDENT on his Roland mill in zirconia, and that 3 1mm connectors have been nearly flawless. So on the question of what connectors are right, I think there's a lot of different answers to that, and it depends on kind of your specific mill and the material and where you position them. So there's a lot of variability in that, but there's a lot of different ways to find the right answer to that.
Yeah. So like I said, that the 3 millimeters, that's just what I use. Yeah, your mileage may vary. So as far as the toolpaths goes, or whatever tools you're going to be using, one way to check is in your HyperView. After you've pulled up the toolpaths, you can right click on this right here, like the name toolpaths at the beginning of the list, and press tools. This is going to give you a list of every step. See job 24, job 24. It's going to tell you the tool, the diameter, and everything like that. Another way to do it is if you have a specific question or you want to know a specific steps tool with a picture, you can right click on that step and hit tool. That's going to bring up an exact, essentially the STL of whatever tool you're using. You do want to check sometimes if you are having issues that this matches up with what you're putting inside of your machine. So this NC number right here is essentially the number that your machine recognizes that tool as. So if you purchased a tool from some supplier and they call it a T1, you're going to want this number to match that number. Okay. But yeah, this is going to give you all the information you need to know about your tool that you're going to be using for your step. All the dimensions will be listed right here. If you have a question about which dimension is what, you can always press it like that and find out which one it is. You can find out the identifier, which is essentially most of the time going to be the type of tool and the size of it for the diameter. But you're also going to get the type and the diameter down here as well.
Great. And one more question here from the audience. Gentleman's wondering if they only have an STL file without a construction info file. Can I correct if there's a mistake? So I think in that case, really, it's basically entirely up to you to identify the margin line and a lot of the other critical features of the part.
Yeah, exactly.
In the absence of that construction info file.
Mm-hmm. Yeah, HyperDENT is super flexible with allowing you to grab whatever coping line that you want to grab, or any margin line, anything like that. If you can't grab it automatically, you can also just do it manually. I'm not going to go into the specifics of just grabbing margin lines, but that's going to be up here in identify part features. Okay. So you can do it manually or automatically, but yeah, you can definitely do that. The construction info isn't a necessity, it's just a luxury. It's just going to make your time a lot quicker. You're going to be able to produce a lot more if you don't have to waste time just marking everything off the bat. Okay. The one thing I will go over for part features are user-defined lines, which I find are pretty important. I'm just going to stop this job.
Actually, one other thing that we have, Kyle here wondering regarding angulated screw channels. When setting them up, he finds he has to separate the channels. He's asking, can you cover this and why those channels might need to be separated?
Okay. Yeah, so that goes back to what I was talking about with the angled screw channels. So if I had an angled screw channel, for example, so if I had an angled screw channel, that's really going to depend on your specific templates that you have for your machine. So I would reach out to whoever supplied you your machine and your templates to ask them how exactly you should be going about it. But to separate the screw channels, that just means that you want to use the normal screw channel steps, not the angled screw channel steps. So like before, where I was saying, if HyperDENT recognizes it as an angled screw channel, it's going to take a different set of steps to get it done. Right? So it's going to calculate it saying that, okay, I want to stop the drilling right at the angle as opposed to going to the end of the channel as you would do for a normal channel. So when you separate it, you're essentially telling it, I want you to just use normal strategies to mill out whatever screw channel and not really get too in the weeds about it. Okay, so this one's a good example here. So this one I nested like that, where I separated the screw channels and I deleted stuff. You'll see here that I didn't need to. So this is the only screw channel I have selected here, just because I know that I can make it just drill this and I'll be fine with it. But if you did have another channel down here, because once you separate it by honestly just right-clicking on the screw channel and you're going to get a separate screw channel button. So if I selected specifically the screw channel, not the STL, and right-click on it, there is a separate screw channels button. That's what you're going to do to make to essentially get rid of the angle and have two separate channels. If you do that, you're definitely going to want to delete the channel that doesn't look like a screw channel, essentially, because you don't want it to sabotage the rest of your mill if you have a drill going in a random direction. Okay, so if you are going to do that and get rid of one of the channels, you want to make sure that your pathway is clear all the way around. All right. So once again, you just right-click on the channel, hit separate screw channels. Okay. Is that clear? Or does that answer your question? Okay.
Yeah, it looks like that covered it. Thank you.
So next I'm going to talk about user-defined areas really quickly. So if I have a full arch, something like that, I wouldn't need to do that for here, just because as you can see here, the boundaries are a little different, what I was talking about before for 90-degree milling or C-clamp milling. But if I had an issue on another STL or something like that, and I wanted to make sure the interproximal areas were being taken care of or some undercut areas are being taken care of in separate steps, I'm going to come over here in margin lines, come to type, hit user-defined area. So this is if you have something where when I look at it from the top, I look at it from the bottom, I can't see a certain part. I'm going to want to come into here for user-defined. Once again, if I press that too quick, you're not going to be drawing anything until you press this button, draw contour. Okay, so whichever direction I choose, I start drawing this line will be my insertion direction for that step. So user-defined line essentially creates just a few extra steps. If you have it in your template, once again, that will basically go over with a tool to try to get some areas that probably have some undercut. If you're ever wondering what part of this STL is undercut, you can always just come over to here to automatic detection of the undercuts. And it's going to show you in red everywhere that it thinks is going to have undercut if you were just to mill it as is. So as you can see, a lot of that are the interproximal areas, especially on the facial side up in here, which is super important for something like full arch, or if you're milling a tie base with notches on it or something like that, you're going to want to essentially draw your own user-defined areas. If I come over here, if I'm being cognizant of the direction that I'm drawing from, you're going to want to not get too crazy with it because every machine has its limits on the angle of insertion direction. Okay, so that's another thing you're going to want to check with your reseller to make sure that you're staying under that insertion, that highest, or I guess limit of angle of insertion. So what I usually do is I come from either the occlusal or cavity side, depending on which way I want the tool to come in. And I'm gonna go, the first part I'm gonna call a limit is probably when this boundary line intersects this middle one. Just generally, I know if I go too far off that, I may be creating too much space, have an angle that's too high. But I mean, obviously that's not too much of an issue because you can always change it after the fact. So if I draw, let's say, a line from here, so once I hit 3 dots, it's going to be a lasso. Now you can do this different ways. So I can either draw a line myself like that, hit accept. Now I have a line from there. Or new in version 9, you can select from the undercut areas. So maybe a little quicker to even just come over here. Once I hit that, I can just click on a user-defined area, and it's going to try to automatically draw a user-defined line for me.
One question we have here from Kyle is when it comes to 90-degree milling, so this is a case where you'd be using that C-clamp or an open fixture to be able to, access like the facial side at a 90-degree angle there. Mm-hmm. Does this user-defined area need to be set in the template, or can it be done in the template generator light? It sounds like Kyle is looking for a way for this user-defined area to kind of automatically be kind of in that, critical aesthetic area there in the front.
The placement of it, no, you can't have automatic selection of it. Really the only thing, so for something like that, what you want, if you do have the template generator, you're going to want to add certain things like automatic rest machining and stuff like that. That's going to get most of this stuff for you, but that's not going to create a specific insertion direction like you would with the user-defined line. If you know that there's a certain area that you can get, if you just were able to tilt the puck just a little bit, I would use this one instead. The automatic rest machining, depending on where you get your template from, chances are you probably already have that for something like a full arch. But this is something to go in a different direction rather than just to do a once over. So yeah, there's not going to be anything automatic on that front. At least for this new, I can speak for our strategy right now. The C-clamp milling for at least any full arch that you do, you won't need to really do any user-defined areas. All you need to really do is just nest it up in the front. Okay, so something like this, where you see that the boundary line has opened up. This is essentially the roughing line, or the space that's going to be created in the beginning of the job. The version 9 has pretty much optimized this to be able to do it without user-defined. If you are still feeling worried, you can add it if you want, but it's not really necessary at this point. So yeah, honestly, that depends on your template, but yes, you can have it automatically milled, but it's not going to create its own direction. It's going to essentially just do the normal direction. If you have another area that you want to go over and from a different angle, then yes, use the user-defined. Okay. All right, so I don't have too much time left, so I'm going to go over a few quick things that I feel like are super important for everybody. One is making sure that your angle of insertion isn't too crazy. Okay, so no matter what machine you're using, chances are you have a limit on how far you can go with some angles, either whether it's on a screw channel, a user-defined, maybe coping line, abutment base, or anything like that. Whenever you're about to mill something and something looks like it has a pretty high angle, maybe this one, for example, nothing is too extreme on here, but if I hover over whatever part, it's going to, okay, this one's pretty extreme. So as you can see right here, if I hover over the part, all I'm doing is moving my mouse over a selected part. This little dialog box comes with the maximum insertion direction angles. So if you know already what the limits are on your machine, you're going to want to make sure that these numbers fall below it. Okay, so I would reach out to your reseller or wherever you purchased your machine from and try to find out what that is, because that's going to be key. Because if anything goes over that limit, chances are you have some type of blocking on your post processor that'll stop you from doing that. Which goes into the last thing I want to talk about are errors, common errors. A lot of people have a lot of calculation errors that can drive you crazy, and you don't know what to do. So easy ways to pretty much troubleshoot or try to remedy whatever calculation errors you have. The first thing I would say is just read what the red text says. That's going to give you your biggest clues to trying to figure out what went wrong and how to get around it. A lot of this is an example right here, but there's a bunch of different ways that your calculation could have gone wrong. These right here are big ones, or ones that I see a lot, pretty much. Collisions happen all the time. You want to see that in HyperDENT because you don't want to see that in your machine, right? So if you do see a collision, take a second to try to find out which step is actually causing the collision. The text may be a little small here, but a lot of the times this one says screw channel machining. So in this little screenshot example, you want to see what that is and how you can get rid of it. So if I saw something like a screw channel machining having an issue or having a collision, I'd probably try to move the STL either up or down, depending on if it's a cavity side or an occlusal side collision or something like that. But yes, that is the first thing you want to do. Make sure you move it around, try to get it to a different spot, or double check to see that you've corrected or you've selected the implant channel properly, or the screw channel, or the hole. Double check all your margin lines or the identify part features button. Yeah. So if you see something called error reading or executing script, that's usually accompanied by a long line of text that you'll see a bunch of these lines. So this is only 2 collision error. It's pretty simple. It tells you where it stopped and because of what step. If you have an error reading script or executing script, chances are just go ahead and try to restart HyperDENT and calculate it again. Okay. No solution for toolpath. This is also a common one that people see a lot. That's also sometimes accompanied by a long text, or you'll probably see HyperView automatically open up when you're at like 99%. That's a post-processing error. Could come from different things. Chances are you maybe have gone a little too high with the angles. Those max insertion angles I was talking about before can really stop you in your tracks if you go a little too high. So you just want to make sure that you're staying under that limit. If you go over it, chances are you're going to get a no solution for toolpath error. Tool too short is also another one that people get a lot. There's no way to really get around that. If you don't have a tool that's long enough for a screw channel that you've nested, you either have to shorten that screw channel, edit your STL or your design, or you could just try to move the puck or move the part towards whichever side is causing the issue. For example, for starters, lowering the insertion angle. So if I wanted to lower this one, there's multiple ways to do it. So I can either start by just rotating it, which is the simplest way. So if I double click, and just try to rotate it to get the X and Y probably a little more equal to each other. You can do that.
Yaphet, one question we have here from the audience when it comes to the errors that you're going over, and I think it's an important distinction to make because the person is asking, are these errors fixed in the new interface or version? And correct me if I'm wrong, but like the errors that you're describing aren't really an error with the program itself. It's more of a user error in that you're asking the software or hardware to do something that can't really be done. Is that fair to say?
Yes, that's exactly correct. So that's what I was saying before, where that when you see an error, a calculation error in HyperDENT, that should be a good thing for you because you don't want that error or that calculation or collision to actually happen in your machine. It's essentially a safety feature. So it wants to make sure that you've nested it correctly so that you don't do any damage to your machine or any of your parts, right? So yeah, so it's not really a bug or anything like that. It's more of a feature. Okay, so aside from just rotating it, I can actually move or rotate the whole part or the milling direction. That's where this button comes in, set milling direction. I personally do not like to rotate my part from the side by double clicking on it and trying to rotate it like this. All right, I'm not gonna waste too much time on that. But that's called rotating in the blank. That's functionally, that's fine. You can do that. But I feel like it takes up a little more space because you see how the boundary lines get skewed, and you don't really want that. If you want to keep your boundary lines the same, you just want to change the milling direction. You can click on your part. Or identify part. Okay, sorry. Set milling direction. And you can essentially just change what is called the occlusal direction of your part. So if I wanted to, get that down a little bit, I can just come over here, base it, make sure it's a little less severe, hit occlusal. So what this button does is saying, whatever view I have right here, that's the new occlusal direction. Forget about what it was before. This is the new occlusal. If I hit cavity, I want this to be the cavity side, and I want this to be the occlusal side. And you can see instantly that lowers the highest insertion angle. Okay. You may have some restrictions on the height of your blank or whatever puck that you're putting it in, but that set milling directions is a really useful feature for lowering the angle and the height to try to get the most out of your puck. Another thing that might be helpful if you're having an issue where you've tilted something a little too far and you're saying, okay, hey, I didn't want to change the occlusal part so much because I want this. You can also right click and set an occlusal direction. This might actually, this might be more helpful with abutments, like titanium or custom abutments. If you want to tilt the abutment to change maybe the angles of insertion on the screw channel, but you don't want to you still want to be able to get around the whole emergence profile. You can change the view. Right click and hit set occlusal direction. Once you've done that, you're essentially telling it, okay, even though that is faced this way, I still want all the occlusal finishing steps and things like that to come in this direction right here, which will, if in the example I was talking about, would pretty much allow you to get around your whole titanium abutment or something like that. Okay, so I am running here at the end of the time for today. Right now, I don't really have too much time.
Yeah, well, I mean, we have a couple of questions to go through, so I think we'll continue going through these as long as folks have them. But if anybody needs to drop off, that's no problem. We have a question here about HD parts files. So this, for anybody who's not familiar with them, these are HD PARTZ files. And the question is, how can I have or obtain HD parts files? Are these files available to download? Is there a tool to save or convert STL geometries to HD parts files? Please explain more about this type of file. And I believe the HD parts file is something of a utilitarian thing within the HyperDENT process. Is that right, Yaphet?
Yeah, super useful. HD parts files are essentially just STL files, but with HyperDENT information on it. So these parts only open up in HyperDENT and are helpful if you want to re-nest something for whatever reason, and you don't want to have to mark it up again or orient it again, because it also, HD parts file, includes the every marking that you've had on the STL and all the orientation changes that you've done. Saves everything but the connectors. That you'll just have to redo, but still super useful. If you nest bars and abutments, the geometries that you put on your implant interfaces, those, for example, are HD parts files. But for example, if you wanted to convert some STL you had into an HD parts file, easy, quick way to do it. Click on whatever part you want to save. There may be another button to do this, but the way that I use it is I come into Extras, Execute Command, and there's a list here. You may not start with Save Part, but in the drop-down menu, you want to go to Save Part, Execute. And now, your two options here are HD Part and HD Part Z. So the HD Part Z is the one I use mostly. That's going to include the orientation direction. So yeah, so from there, you can just save it wherever you want, call it whatever you want, and you've saved that STL as an HD parts file. So I can renest that and open it up in HyperDENT or another window of HyperDENT, and it's still going to contain all the information I already put on it. I will say that version 9 also does automatically save whatever changes you make on the STL as an accompanying file, same way you'd have a construction info and things like that. So that does make it a lot easier. So if I were to bring this STL, open the same STL from this file path in another window, all these little markings that I've made, all this implant interfaces that I've selected, abutment bases, directions, things like that, will also already be saved. But that's new to version 9. If you have an older version, definitely you're going to want to use Extras, Execute Command, Save Part to save the HD parts file. Does that answer your question?
I think so, yeah. So I think we'll return to that if we need to, but moving on to some other questions here. We have one person asking, could you explain, please, more about the STL reducer, which is not something I'm familiar with, but hopefully that is something you're familiar with there, Yaphet, the STL reducer.
Sure. The STL reducer is pretty helpful if you ever are having an issue with maybe too big of a file size. Typically, you're probably going to want to reduce anything over maybe 30 megabytes. It's not super necessary. It's just going to free up some, CPU or space on your computer, and also allow it to run a little bit faster if you're running into some issue where it's either lagging or having an issue starting up a calculation or something like that. You're going to want to take whatever STL you have, come into Extras. All right, STL reducer. So this can also be done on a third-party app or another app. Mesh Mixer is a good example. But essentially what it's taking is it's going to constrict the number of triangles that are used to make up that STL, just to try to reduce the size. You're not going to really see too much reduction in the actual visual quality of whatever STL you're using, but you will see a significant difference in the file size, which will help it run a lot easier, just allow your computer just to have an easier time. So to use STL reducer, it's pretty simple. So we're going to come over to this first box. We're going to open. I'm going to choose some STL. Let's say this, if I had some crown. Open it up. And really all you have to do is hit start. The tolerance and angle, you can change how much it actually reduces the part. I would stick with the default. You're going to be fine with just the default. You can always just bring up that reduced one again in here if it's really causing an issue. But this is significant enough, 0.05 and 20. And then once it's done, you'll see, so all I did was hit start. I don't know if you saw that. Hit the start button. All I did was bring in the STL or choose my STL, hit start. And once it says mesh reducing was successful, you'll see the size difference. Used to be 0.9. Okay, this one isn't as severe, obviously. This used to be 0.97 megabytes, and I just reduced it to 0.4. It's probably more helpful with something like a full arch, But yeah, not necessary, but just helpful for your computer for sure.
Great. So another one here from Claudio. For a proper fit to the tie base, do you manage it in the parameter of finishing inside the abutment bases? And if so, what parameter do you apply? This one kind of sounds like it might be something to deal with template generator light as well, right?
Yep. So if you don't have a button here, that means you don't have template generator. There is a newer button. I think you're on about version 8.2 and above. Template generator of light. It's going to have a little plus button instead. That's going to give you options to change a few steps. The one you're going to want to do for tightness of the tie base, yes, is the finishing inside abutment bases. You can change the allowance on it, which is essentially how much rest material is left inside there. So you can change kind of the fit just by tweaking it a bit. You obviously don't want to go too crazy with it because you might start losing some of that shape. But if you are having an issue with something being consistently too tight and you want to change it in the strategy, so it's going to look a little different in template generator light, but this is what just template generator looks like. So just so you have a visualization of like the terminology that I'm using. So if I go to finishing inside abutment bases, you're not going to get all this for template generator light. The only thing you'll probably get is allowance. This is all, if you don't see it also, you can just ask whoever gave you your templates and they can enable it for you. But this allowance button or this allowance value right here is what you want to mess with. So as you can see right here, this is the definition for the allowance. But if I wanted to make it a little looser, I'm just going to go like negative 0.01 or something like that. Stay in the hundreds. If you go a little too far with the millimeters, you're going to end up with a messed up product. So I would probably try like negative 0.02 or 0.03, maybe even 0.05. And that's just going to make it dig a little deeper on that one step. Okay.
So that's a great question about